Hi everyone, let us discuss this example. So in this example we have this equation and we have to prove that it has a solution, right, in this interval 1 comma 2. So let me write a given equation. We have x square is equal to root x plus 1. I will take all terms in left hand side, so we'll have 0 in right hand side. So therefore x square minus root x plus 1 is equal to 0. So whatever the function we have got, we will call it as f of x. So let f of x is equal to x square minus root x plus 1. We have to prove that it has a solution in this interval. We are going to use Bolzano's theorem, okay, to prove it. But the condition is that the function must be continuous on the given interval, then only we can apply Bolzano's theorem there. So yes, let us this is a continuous function since x square is a polynomial function, right, as well as x plus 1, that is also polynomial function. We are taking a square root. You know that f of x is equal to root x is a continuous function, right? It is a continuous function on closed interval 0 comma infinity. So that means whatever the inside square root should be non-negative, that is a condition. So then square root will be a continuous function, and we know that composition of two continuous function is again continuous, so that's why we can say it is a continuous function. So what is our conclusion? Our conclusion is clearly f is continuous on 1 comma 2. Since if you take any point from this interval and if you put it here inside a square root, you will never have negative number. So obviously it's a continuous function. So it is continuous on closed interval 1 comma 2, right? So now we can apply Bolzano's theorem. So for Bolzano's theorem, at two different values of x, we should have opposite signs of functions, right? Plus and minus. Then Bolzano's theorem says there is a solution between them. Let us find what we want to prove, solution between 1 comma 2. Now, so let us find f of 1. So f of 1, that means I will simply x is equal to 1 here, 1 square is 1 minus 1 plus 1. So this is 1 minus root 2. You know that root 2 is greater than 1. So if you are subtracting a larger number from a smaller number, definitely we will have a negative number. So that's why it has a negative value, right? Let us find the value of f at 2. Let us see what will happen if I put x is equal to 2 here. 2 square is 4 minus root 2 plus 1, that means 4 minus root 3. See, obviously 4 is greater than root 3, so that's why it's a positive number. Getting? It's a positive number. So negative number at 1 we have a negative value, and at 2 we have that function has a positive value. So therefore by Bolzano's theorem, by Bolzano's theorem, or you can say by intermediate value property also, okay, by intermediate, it is a generalized case of this Bolzano's theorem. So Bolzano's theorem or intermediate value property, f of x is equal to 0 has solution in 1 comma 2. So Bolzano's theorem says f of x is equal to 0 as a solution in this interval, since at 1 we have a negative value, at 2 we have a positive value. So definitely it has a solution between them. F of x means what? Let me put it here. It is x square minus root x plus 1 is equal to 0 has solution in this interval. Let us shift root x plus 1 on that side. X square is equal to root x plus 1 has solution in closed interval 1 comma 2. So in this way we completed this example. Make a screenshot of it, then we will stop. Thank you. Bye bye.